Okay, so I'm going to talk a little bit about the Unix file system and disks and whatnot. The Unix file system is essentially like a tree. The top of the tree is called the root. Weird, right? The top's the root. Well, it's like an inverted tree if you want to think of it that way to make you feel better. So the root is represented by a single slash. Um, in Windows world, we'll have like a C at the top of our structure, or a D or E. In Unix, everything starts with a slash. So even if you have other partitions on there, they're going to start with slash, and we'll talk about how that works in a little while. So the slash is the top. If you do ls, all these other directories are below the slash directory. The book goes through what all the different directories are used for. I'm not going to go through all that. You guys can read just as well as I can, so I'm not going to talk about what all the directories are for. That's in the book. The slash is the top of the tree. Everything else is attached to the slash. So to make this happen, we need a disk or disks, right? Within that disk, we have a partition or multiple partitions in theory if we want to separate our disk into multiple partitions. What's the benefit of that? Well, if we are filling up a particular file system, if we separate the different file systems from each other, then that will protect the system a little bit. For example, if you look at /var, we have a log directory. So there are some processes in place that keep the log directory from filling up and completely sometimes. But the chance exists that you could fill up the file system based on the amount of log data you're writing. If everything is mounted on one partition as it is now, if I fill up the var file system, then there's going to be no space available for the system to use to do other things it needs to do, and the system will eventually crash. However, if I was to create multiple partitions and I had the var file system mounted on a different partition, then if that var file system filled up, it would be segmented off from the rest of the system. So the system could keep running. We would just not be able to write any more log files. So that would be the benefit of having multiple partitions. It's really a best practice. It's recommended that you do that when you create a system. You create separate partitions for the separate different types of data you're going to have in there, so that the system is more stable and more available. So we will have a disk. The disk will be partitioned into multiple partitions, or we could just use the whole disk if we want. And then we need to create a file system. Our book talks about some different file systems. It talks about UFS, the Unix file system. That was the original file system that gave us our hierarchical tree structure. UFS supports journaling. Journaling is where the file system keeps track of changes that are made, because changes don't immediately get written to the disk as they are made. The system will queue up some changes and write them to the disk as it goes. So with journaling, it keeps track of the changes that have been made. So should the system crash, it can recover by rewriting what didn't get written to the disk based on what is in those journal files. So journaling is a good thing. Linux used the extended file system, or ext. It started out with ext, the first version. It could only support files up to 2 gigs and apparently had some other bugs. According to the book, there were 3 more versions of ext since then. ext2 added support for larger files. ext3 added journaling, and ext4 added extents. Extent will reduce fragmentation within the file. So as you may or may not be aware, the data on the disk is actually stored in blocks. So a file the data for a file will get written to a particular block. When that block is full, then it needs to start writing into another block. So the problem with that is if there are no contiguous blocks near the block that just filled up, then the system will write to a block somewhere else on the disk, and that will cause it to take longer to display the file, because it has to go to one part of the disk to get part of the file and another part of the disk to get more of the file. So the extent causes it to write, pretty much save some space where the file's starting, so that there will hopefully be room to put more of the file in the other blocks nearby. So that's a ext4 function. So as I said, the top of the tree is the root. All these directories underneath it. Bin, data, Etsy, lib, media. These are all directories under the root. Each of these directories can have directories within it and files. So if we go to the Etsy directory, if we look at this, all the blue, I guess that's blue, maybe purple, I don't know, colorblind. All the colored names or directories, all the white looking ones are files. So every directory can have files and directories within it. So